Okay, today we're going to be looking at mutually exclusive outcomes. So let's think about what that actually means. So imagine you roll a dice. So in a dice you can get 1, 2, 3, 4, 5 and 6 outcomes or events. These are said to be mutually exclusive, meaning that if one happens, the others do not. If you get a 4, you're not going to get a 6, which seems very logical. However, this is not the case if you think of a pack of cards. They're not mutually exclusive. The outcome that it might be a heart, another is that it might be a king, but they're not mutually exclusive, since you can have a card that is both a heart and a king. So what we say is if the events A and B are mutually exclusive, the probability of A and B, or A or B, sorry, I'll write that again. The probability of A or B must be probability of A plus the probability of B. So if you were saying what is the probability of rolling a 3 or a 4, you would add the probability of rolling a 3 plus the probability of rolling a 4. Let's look at an example. So in a canteen, the breakfast menu has 4 options. Some are more likely than others. The table shows the options on a day together with their four possibilities. So the food, the probability, so we've got sausages, and the probability of having a sausage on any given day is 0.3. Fish fingers. Who has fish fingers for breakfast? Probability of having fish fingers is 0.4. It's a very strange canteen. And then bacon and eggs. Probability is 0.1. And then finally cereal. But we don't know what the probability of cereal is. Funnily enough, the first question is find the probability. What's the probability of cereal? So let's think about that. The probability of cereal must be 0.2 because they're mutually exclusive. 0.3 plus 0.4 plus 0.1 is 0.8, and then we take 1 minus 0.8 equals 0.2, so probability of cereal is 0.2. Find the probability that the breakfast available on a randomly chosen day is sausages or bacon and eggs. So we're going to take the probability of sausages, which was 0.3, and add it to the bacon and eggs, which is 0.1, which gives us 0.4. And what is the probability of not fish fingers? Well, that'll be 1, because their probability of them all together is 1, minus the 0.4 equals 0.6. And one other little point to make about this before moving on, if we have a set of probable results in an experiment, they're said to be exhaustive. If no other score, so if, say we've got a set of outcomes for rolling our dice, we've got our 1, 2, 3, 4, 5, 6 obtained by the rolling of the dice. There's no other, if no other score is possible. So if this means if the outcomes are mutually exclusive and exhaustive, then the corresponding probabilities must all, the probabilities will add up to 1. So with the fish and chips, the breakfast menu problem, if you added all the probabilities together, they added up to 1. If you add up the probabilities of all the different rolls of a dice, they'll add up to 1. So I hope that helps.